Okay, hey guys, welcome to lesson 17, graphing linear equations. So the idea with this lesson is that we are going to be working in the mysterious world of the Cartesian plane. Now, I know you have seen this image before, so let's just go over some basic anatomy of the Cartesian plane. First of all, we call this whole thing the Cartesian plane, and every point on this plane, meaning, a location in that 2D space, represents a pair of numbers. Now, horizontally, we have the x-axis, and vertically, we have the y-axis. So any point on this plane can be represented by its horizontal position, represented by the number marked on the x-axis, and its vertical position, marked by the number on the y-axis. In this case, this point is the point 3, 6, because its x-coordinate is 3, and its y-coordinate is 6. So with that out of the way, each pair of numbers represents, every point represents a pair of numbers, x, y. Now, the question is, can we take statements about pairs of numbers and turn them into pictures on the plane? And the answer actually turns out to be yes. So just remember that an equation, very simple equation or a complicated equation, is just a statement that is true or false depending on the variables involved. So let's look at an equation like this one. X equals -2. In this case, to draw the picture of this equation would be to draw all points where x equals -2. Now, what that means is the graph of this equation is just going to be a drawing of anywhere on the line where a point has an x-coordinate of -2. Now, we know that the x-coordinate -2 is over here, but this point that I've just drawn has an x-coordinate of -2 and a y-coordinate of 0. And I think we should note that it doesn't really matter what the y-coordinate of a point is if all I'm requiring is that x is equal to -2. So the graph of this line would look like a vertical line that crosses the x-axis at -2. And I would just draw some little arrowheads to indicate that it goes on forever. Let's look at another example. If I write down the equation y equals 3, what I would like to do when I graph this equation, it'll tell me to graph the equation. What that's saying is, let's draw a picture of every single place on this graph that has a y-coordinate of 3. So if we were to do that, I know on the y-axis, 3 is right here. So I know that this point is on the graph. But also notice that as long as I keep my y-coordinate 3, I can move anywhere I want to the left or right as long as I don't move up or down. So to graph this equation, I would just be drawing a horizontal line, because what I've just done is I've kind of painted in all of the points on this plane that have a y-coordinate of 3. Your equations can get a little more complicated, though. Let's take something that has both variables in it, x equals y. So this equation, x equals y, if I'm asked to graph it, what that means is I need to draw a picture on the grid of every single point where the x-coordinate and the y-coordinate are the same. Now, one example of that would be the point 0, 0. This point is called the origin. The origin because it's 0 on the x-axis and on the y-axis. So I know that x equals y at this point, but what about some other points? Well, if we go to x equals 1, y equals 1, then it's true that x equals y. if we go to -1, -1, it is also true that x equals y. So to graph the equation x equals y, let's just come up with a few possible x's. And this is where we're going to bring in a thing called the xy table. Whenever we have an equation that has both x's and y's, here's what we do. We start by choosing a few values of x. And when I say choose, I mean actually choose. You can choose whatever you would like. However, remember that since you're trying to draw a picture, you should choose x coordinates that are near 0 so that you can draw your picture and you don't choose 110 or something, and that would be far too far off the graph. So here, if I choose, basically the most common numbers that I see being chosen are -1, 0, and 1, because it makes the calculation really easy. In this case, all I'm asking is that x and y are the same. So if x is -1, then y would also be -1. If x was 0, then y would also be 0. If x was 1, then y would also be 1. So let us draw those points on the graph. -1, -1 is this point right here. 0, 0 is this point right here. And 1, 1 is this point right here. And now I guess you can probably see that there's a pattern. 2, 2 is also going to be on that line. 4, 4 is going to be on that line. -6, -6 is also going to be on that line. And so what you have is just a line that connects every dot that I've drawn. Usually, once you put down 3 dots, it will be very clear what the line looks like, and you can just draw it straight away. So you don't need to have like 5 points on the line to be able to tell what the line looks like. All you need is 3 or 4. So once you've graphed that, label it with the equation so that on the homework I can see exactly what line you were trying to draw. Now your equations can look a little more complicated. Let's get an example where there's both x's and y's in the equation, but something's being done to the x. Y equals -2x minus 1. Oh, y equals 2x minus 1, excuse me, is our new equation. And for this, we're actually going to do the same process that we did last time. So this x can be whatever you want. Let's choose several values. I'll choose the same ones. Actually, now mix it up a little. Let's just choose some different ones, -2, 0, and 2. Now what you do to write down the second column is you just plug in x and find out what y would be. So we start with the first x, -2. We're trying to plug in x to this equation, so all we have to do is 2 times -2 minus 1. For x equals 0, we would be doing 2 times 0 minus 1. And for x equals 2, we'd be doing 2 times 2 minus 1. Now we have to simplify and figure out what the values of these are. I know that -2 times 2 is -4, and if I subtract 1 from that, that gives me a +5. Or obviously not a +5. I meant a -5, so we'll remove that in post. But yeah, -5 is your value for y when x equals -2. Now let's look over here. 2 times 0 is 0, minus 1, so it gives you -1. 2 times 2 minus 1 is +3. So in this case, we have 3 pairs of points. Well, 3 pairs of numbers, -2 and -5, 0 and -1, and 2 and 3. Now, if we go to our graph, we can actually draw a picture. Because now that we've found the values, we're going to draw a point on the graph for each of these pairs. Okay, let's look at the first one, -2 and -5. If I go to the location for that, I go to -2. Then I go 5 down. 1, 2, 3, 4, 5. So that's where the first point of this graph is. Now let's look at the second point. X is 0 and y is -1. So that means horizontally 0, and then we take 1 step down. Wow, so this guy is kind of steeper than the other ones. Now let's look at this one. 2, 3. So x is 2, y has to be 3. X is 2, so we go to the horizontal position of x equals 2. Then we go up to y equals 3, right here. And if you see these 3 orange points, they lie on the same line. If we get our straight edge out, we can actually draw a line connecting all 3 of those points. Now, if you do all of your calculations and you come up with 3 points that don't all lie on the same line, then you're going to know that either your equation is nonlinear, which won't happen in this class for now, or you probably made a mistake. So I would just write down y equals 2x minus 1 once I am sure that all 3 of the points I've drawn lie on the same line. So these were both examples, y equals 2x minus 1 and y equals x. They were both examples where we had a y equals and then some variables and constants. So one thing that can happen is that you might be given an equation that does not have it in that nice form. So let's look at this example right here. 2x plus 2y equals 4. This is not solved for y. And actually, whenever we graph a line using this table method, we are going to need to solve for y first. Because if I plug in an x here, then I still don't know what y is, right? If I plug in something here, I'll still have to solve for y. So do that first. Let's go ahead and start by solving for y in this equation. So we start with 2x plus 2y equals 4. Now let's move things away from the y. One way to do that is subtracting 2x from both sides. So now we get 2y equals 4 minus 2x. Now we can divide both sides by 2, remembering to distribute that division across the sum. Then we get 2 minus x. Y equals 2 minus x. This is easy enough because now we can plug in any x and figure out what y is just like that, just by doing a tiny little calculation. All right, so I know I kind of encroached on this column here, but I'm just going to write my, there we go. I'll write my x's right here and my y's right here. Let's choose, I don't know, the same ones. 3. Oh, wait a minute, we can choose new ones. Yeah, let's do 3, 0, and -3. I like making the x values evenly spaced, but all that matters is that your points show up on your graph. So just make sure these numbers aren't absurdly large and make sure they are not fractions when you end up doing your calculation. So in this case, we started out with this equation, but we were able to rewrite it in a much nicer form. Y equals 2 minus x. So all we have to do is take the x's and plug them into 2 minus x. When x equals 3, 2 minus 3 is -1. When x equals 0, 2 minus x is 2 minus 0, so that's 2. And when -3 is x, then we just take 2 and we subtract -3. Remember that subtracting a negative number is adding, so that would be a +5. 2 minus -3. So we go up to our graph now that we have 3 good points, 3, -1, 0, 2, and -3, 5, and we just plot those out. 3, -1 is our first point. That means x equals 3, y equals -1. So that would be right here. Let's use a different color for this. I'm running out of colors. Oh no. Let's do pink. 3, -1 is our first point. Then let's go back down to our table. 0, 2 is the next point. X equals 0, y equals 2. So as we can see, this point tells me that this line actually slants downward. That actually has something to do with the fact that we're subtracting x. So values that we plug in for x will get their sign flipped. Now, the last point we have is -3, 5. So I go to x equals -3, y equals 5. That is where my third point lies. Now, we got 3 points, and that is nice enough to finally create that line. Notice it's a sloping downward line, and I will write the equation right next to it. Now you can write 2x plus 2y equals 4, or you can write the simplified version of the equation. But just for simplicity's sake, so we can attach it to the right problem, 2x plus 2y equals 4 is the label I'll give to that point. So let's summarize. When we're graphing linear equations, first we start with the question. What does the equation look like? If the equation is x equals some number, so like that example we did, x equals -2 or x equals 3, then your graph looks like a vertical line that crosses the x-axis at that number. If we have an equation that is y equals some constant, then our graph looks like a horizontal line that crosses the y-axis at that number. So that would be something like y equals 1, y equals 0, or, of course, it could be a negative number too. It could even be an irrational number like y equals pi. The only requirement is that x equals a real number or y equals a real number. So I guess the thing to remember here is just x means vertical line, y means horizontal line. But of course, that's not the only thing. That's not the only way an equation can look, because sometimes these guys have x's and y's. So if the equation contains both x and y, here's what you do. First, ensure that your equation is solved for y, and that means you've got y alone on one side. Make it look like y equals some stuff. So in the examples that we did, we had something like y equals 2x minus 1. We also had something like y equals 2 minus x. So this is an example of a solved for y equation. Once you do that, make a table. So if you have solved for y, make a table. First, choose 3 to 4 values of x, usually 0, 1, and -1, but you can also do some other values. You could do 1, 2, and 3. Any values of x that will fit on your graph that you've made. And then proceed by plugging in x, calculating the corresponding y values. So in these cases, we plugged in x to this equation, to the right side of the equation, and we figured out what the value of y must be in order to make the equation true. So once you've done that, you've filled in your different values of y. And then when your table has more than 2 completed rows, plot each pair on the coordinate grid. So that means, if I get a -1 and a 3, then that turns into a plotted point on the line, right? Something like that. Once you have plotted your 3 points, draw a line to connect the dots. If your 3 dots are not in a straight line, you probably made an error, or your equation somehow is nonlinear. Now, because the title of this lesson is Graphing Linear Equations, any graph that you make is going to look like a straight line. So that brings in the last thing that I want to mention, the straight edge. This right here is a straight edge. Another example of a straight edge is a ruler. Anything that can help you make a straight line is absolutely necessary for this lesson. In this problem, every single straight line that I've made, including the y-axis and the x-axis, or the x-axis and the y-axis, was made with a ruler or a straight edge. So that's about all that I have to say. Let me think if there's anything else I should mention. Well, I know that it's Friday, so have a good weekend, but basically that is the end of the lesson. And just let me know. You can post a question in the questions channel. You can send me a message if any of this doesn't make sense to you, or if you need some help on the homework, just let me know. But anyway, that is the conclusion of the lesson. Bye, guys.